Hi, welcome back. Let us look into some of the concepts on Fourier series. Okay, uh, now mathematical formulations and the solutions of physical problems, which I'll be talking about. Now, in solving problems of science and engineering, we need to generally take some mathematical solution for that, and what is the physical interpretation corresponding to that. To achieve such formulation, we usually adopt mathematical models which serve to approximate the real objects under investigation. For example, I have to investigate the motion of Earth or other planet about the sun. We can choose points as mathematical model of the sun and earth. On the other hand, if we wish to investigate the motion of the earth about its axis, the mathematical model cannot be a point but might be a sphere or even more accurately an ellipsoid. In mathematical formulation, we use known physical laws to set up equations describing the problem. If the laws are unknown, we may even be led to set up experiments in order to discover them. There is one such of example which I have given. Let us, I hope you understood this. Let us see another, come back to our Fourier series. Why Fourier series? A Fourier series is a representation of a function as a series of constant times, sine or cosine functions of different frequencies. In order to see why such a series might be interesting, we will look at some of the problems related to that, which leads to Fourier to consider them. Again, if I talk about Fourier's series, which are very important to the engineering and physicists because they allow the solution of ordinary differential equation in connection with forced oscillations and the approximation of periodic functions. Moreover, the applications of Fourier analysis to partial differential equations are given. Now, Fourier series are in certain case are more universal than that is we know about Taylor series, which we already have learned in calculus because of many discontinuous periodic functions that come up in applications can develop in Fourier series but not in Taylor series expansions. That's why we arrive to Fourier series expansions. The Fourier series can be extended into two important ways. We can replace the trigonometric systems by family of orthogonality functions, Bessel functions, and obtain again we have Sturm-Liouville expansions. In a digital age, the discrete Fourier transforms plays an important role. Signals such as voice or music are sampled and analyzed for frequencies. Also, an important algorithm in this context is the fast Fourier transform. Fourier series, in a way, is or are infinite series that represent periodic functions in terms of cosine and sine. I hope everybody understood. These are the basic concepts which I was talking about. So let us again continue because I've been getting a query. So I'm trying to answer it. Okay. So let us again continue. Okay. Now let me explain the next example. Okay, on the how the mathematical formulations and the solutions we provide in a physical problem. Okay, let me again come back.